Welcome to the 56th edition of Botcasters. Today with Tom van der Laan. Tom, welcome.
Welcome, thank you.
Please introduce yourself.
My name is Tom van der Laan. I'm an ENT physician at the University Medical Center in Groningen. I specialize in skull-based surgery, and I do that now for 40% of my time. The other 60% of my time I work as a Chief Medical Information Officer.
And what does a Chief Medical Information Officer do?
It attempts to bridge the gap between IT personnel and the medical field. So to work as a liaison between the two disciplines really, and make sure that the needs of the physicians are well translated towards IT solutions.
And I think that's very important because I found you in an article saying or talking about a chatbot or an LLM being used with Epic in the medical file, electronic patient file, as you would call it.
EMR,
electronic medical record, being used. And that caught my interest. So I contacted you and you said, yes, I come from an ENT family. So I was actually extra interested. And I heard you talk. I just said that to you. If I compare this with my father, well, he passed away a couple of years ago, being an ENT and you talking about technology, there's a very big gap, as you would say.
Gap, yeah.
And I think that's still there with a lot of medical professionals that they're working with technology, but not in the way you are working with technology. So if you could tell me the story, what is it you're currently doing with an LLM and Epic for your patients? And then we dive into that.
Sure. So I think it's been a year now that ChatGPT came out with the first more or less commercially viable product based on an LLM, I think, or at least a more generally acceptable value proposition for the product. And we were very enthusiastical. I was talking to my board member about it, and we were talking about that leading up to a meeting with our Epic representative. And he heard us talking about it, and he said, well, that's very interesting because we've also noticed this development, and we're looking to incorporate this in our EMR, which is for the medical field quite special because usually it takes a very long time before these sort of technologies trickle down to the medical field. And hearing our enthusiasm, he asked if we would be interested to participate in a strategic partnership. Because right at that point, that was, I think, at the start of the year, 2023, they did have an implementation going in the US, but they were looking to implement it outside of the US in a foreign language context. And at that point, we say, yeah, that sounds like a very good idea. So let's see how far we can get. So in the past year, we worked together with Epic to see how the model, which is GPT-4 of OpenAI, who perform in the Dutch language context. And they had a few use cases already developed. We started with generating drafts for the reply to a patient message that comes in from the patient portal. So every patient that has a relationship with a physician or is being treated by a physician or a nurse, for example, is able to text or app the care provider through this portal. And then you can type out a message. It's sort of like an email client. So the first functionality they had in mind was to ask the model to formulate that message initially and put it out there as a draft. So not something that is automatically sent to the patient, but is provided to the physician or the nurse or the other care provider to validate and maybe edit before it can be sent out, trying to see if we can get out that boilerplate text that would be involved, and maybe even a little bit more. And that's what we went live with, and that's what the news communication you found was about. Like the 1st of November, we actually went live with this functionality with just a few physicians, by the way, because we're still in a sort of piloting phase. To see how well this sort of functionality performs and if it can save us time.
And did it save your time, or is it saving your time?
Well, yeah, it does save. It definitely saves time. So if I'm looking at a few examples, I'm one of the piloting physicians. People ask a certain set of questions that have a certain predictability in them. So they'll ask, I went to the pharmacy with the medication you prescribed me. but it didn't have this particular product. They offered me another one, but I'm wondering, is this a proper replacement, and can I be using it? And what happens is that question, alongside with a part of the medical file, is output to the model, and then the model is asked, pretend like you're a physician, you need to answer this patient, and formulate a draft message. And it actually came back with a very clear message, like, look, the brand name may be different, but there's the same substance in there, it's the same dosage, so you should be fine with the alternative that's provided by the pharmacy. And if you've got any questions, don't hesitate to plan a consultation or a phone consultation. Kind regards, Tom. And it's basically a message I can just send like that, so I don't have to go out and type. It's obviously it's not a very big cognitive load, but it's something extra upon my workday, which is already filled to the max. So it's very easy if the model can produce these sort of drafts for me.
And this is a very interesting one, because we know in Holland insurance companies try to push consumers to copies of the medication, not the original one, because they are cheaper, or general
Eric, yeah.
generic medicine, or with generic brands. But does the so you're saying GPT-4 checked if the medication had the same substances in there? Did you check actually what it did, or did you just accept?
Course. So
Oh,
that's the one thing that's most. There's always a human in the loop in these sort of situations, because we talked about this with Epic as well. We're looking not to make it a medical device. If the definition becomes a medical device, so it interferes with the medical process or starts doing things automatically, you go into the MDR legislation.
yep, or
And then,
FDA,
so I'm sorry.
or FDA approval.
FDA approval in the US, yeah, and that's an whole different ball game. So we feel that the advantage that these models provide us right now is more with reducing the administrative burden, to take away a lot of things that are hard to automate because they're soft processes, but always have that human in the loop that needs to validate. So in this case, there's no possibility in the system to send the message as it was generated. You can only say start with draft or start with an empty message. And
Okay.
as a physician, you are responsible for what you're going to send out. So you need to validate that what it spits out, and the assumptions it makes, and the knowledge that is contained within, like these are the same substances, that actually is true. That is a responsibility that remains with the physician or care provider that is sending the message.
And how do you? Because we're looking at human behavior. So let's say you check, and the first 5 times answer perfect. That is really great. So the physician think, this is making my life really easy. How do you prevent the caretaker, the nurse or physician or nurse physician, to just not push the button send before verifying its content, or if a suggestion like you got saying that no, the same substances, blah 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 blah. Um, how do
Yes,
you?
I it's true. And you could consider it a form of de-skilling. If the system provides you with this answer and you start trusting it over time, and you stop checking it thoroughly. However, that remains to be a responsibility of the care provider to make sure that what you send out actually is appropriate, that it is true, that it has been validated. And in a way, this technology doesn't really change that much from the more classical forms of, for example, if I prescribe medications, and there's a dosage simulator, I also get alerts and pop-ups which are just rule-based deterministic forms of decision support. You could say that we have already de-skilled in a way where these pop-ups, I trust that the pop-up about a certain medication, with a patient with a heart condition, is probably not a good fit to give it, that the pop-up will come. So there's already a level of de-skilling going on. But it's definitely an interesting phenomenon. But as it stands, it's the responsibility of the physician to remain sharp, to remain checking what the model spits out. But it's no different from what we've already been doing with more classical forms of automation.
And a question under that is, how do you deal with bias in that? Because I had a discussion with Dr. Harvey Castro. I don't know if you've seen known from online from LinkedIn. He's a very active guy in the medical field. He's a US doctor, ER doctor, also moving into AI field. And one of the problems that these models have is that they are inherently biased. Let's say, for instance, if you take medical information on in GPT, it's probably a lot of information of American research with American patients and some Europeans, but probably less so from Asian or African. So how do you know that the answers you're getting are, or how do you manage the bias? It's in there. We know.
Sure.
How do you deal with that?
So there's bias in there. I think the type of questions we have it answer right now, we are not asking specifically for giving medical advice or really thinking a medical problem through and coming up with an advice. Actually, we ask in the prompt for it not to do such a thing, because that will make it a medical device more than anything.
So you specifically ask it not to act as a medical advisor or a medical doctor.
Yes, do not give medical advice, do not give treatment options or alternatives. So the prompt is actually really, really important in that sense, because there's a lot of things do not that it contains.
That's so funny because everybody's prompting as in, please do act as. You're doing the opposite.
No, we're really trying to stay away from having it become a medical device. I mean,
Okay.
it's definitely going to happen in the future, but your question about bias, for example, becomes way more relevant in that sense. And right now, we're using GPT-4, which is a generalized language model. It's amazing how much medical knowledge it contains, but it also contains information about the history of everything else in the world. Things that don't really aren't really necessary to consider for the particular application that we are using it for. So what I foresee, and Epic has already built around that we'll get models in the future that are more specifically catered towards, for example, giving medical advice when it becomes but also to the Dutch market or to a specific sub-market.
Yeah.
And in the back office of Epic, you can actually switch models. You can also take Facebook's Llama 2 and see how that one performs in that sense.
And the Google has a medical one just came out or fairly recently.
Sure. So there's going to be a competitive landscape of different models that are going to perform differently, and we'll see where we go. But if we go back to the original question about what do you do with the bias right now, the type of questions we're asking or having it answer are less concerned with these particular differences in the medical fields or population.
So
It's
basically,
more
you're using the functionality of the model, not so much the knowledge.
right. So there's this basic form of reasoning. I don't know if you can call it reasoning, but that allows it to formulate a good message. But it's a lot of the questions are concerned like I do surgery. So a patient comes home and they have this question like, when is it okay for me to take a shower? When is it okay for me to take an airplane? Can I go on a holiday? Stuff like that. And it will attempt to answer that question, but it will leave it open, as in I will always need to edit. For example, when is it okay to fly for me after having surgery performed on my ear? And some physicians will say it's 2 weeks. That's I think a more US timeline. In my clinic, it will be 6 weeks, and you'll always have to change that particular part of it. So yeah, you will have to add it, but the real advantage is in that 80% of the message is boilerplate. It's about the explanation why it is important to consider flying if you've had surgery performed on your ear, about pressure differences, stuff like that. There's no bias in there. That's just common knowledge that is shared among the fields. and doesn't have a regional bias.
And a waste of your time to keep typing the same message as a response.
A fun one was I had a patient ask about using the medication. They were going on a trip to Rome, and it would be difficult for them to take their medication on a prescribed timeline, I think. Where the question was, can I take this medication? Is that okay? Can I take it in the plane? And then if I miss my shot at this particular time, what should I do? And it came up with a beautiful answer, like, you can take this, take your forms, take your pharmacy forms with you on the plane. If you miss your shot, it's okay to take it the next day, but do try to keep it as close as possible, which is also appropriate for this particular type of medication. And then it ended the message, and I love that one the most, like, have fun in Rome.
Oh, so it has empathy or something, some sort of.
Yeah. So no, the messages have been evaluated in the U.S. research that to be more empathical than the average message that is set out by a physician, and that makes sense because the physician, for them, is just a burden that comes on top of all the other burdens of having to do their administration. So you'll get a short message like, "No, it's okay, it's fine, you can fly with this medication," but he's not going to spend a lot of time saying, "Okay, and have a lot of fun in Rome, and by the way,
Send me a postcard."
send me a post." Yeah, I'd like to see a postcard. So, no, actually, so the research showed that people preferred the messages that were generated or augmented, if you want, or drafted by ChatGPT, because it simply took more time to explain the question, to go more in depth and try and match the level of understanding that the patient has, and also be more empathic. So, say I'm still in a lot of pain. Can I take this extra painkiller, for example? Could be a question after surgery. Then they'll start off by, "I'm sorry to hear that you're still in pain. That we're going to try and see if we can do something about that. Well, you've said you're already using this and this medication. We could probably see if this one is it, but we'll need to confirm with the physician." So yeah, in a way, it can actually augment the patient experience and make it better than what it is. Yeah.
Well, it's applying psychological principles in communication. This is really interesting. Do you prompt it to do that, or it just did it by itself?
No, it's I think maybe OpenAI has pre-prompted it a little bit to be a friendly responder. But we don't say anything in the prompt by be nice or try to be extra nice or try to be empathic. It does that from itself. You could do it. You could try and expand on it, but we didn't need to.
Yeah, but we're Dutch. We're a little bit. We're not American, right?
Well, you can do that in the prompt as well. So, look, these are a bit. These people don't like overly kind messages. Just reply as strict as possible, and it would do so. It's been quite a journey to see what it comes up with, and sometimes it's not very useful. Then you have to change a lot about the message. But even if you have to change 60%, at least 40% of the message is still time saved. And I think overall, from what I've seen so far, it's 10 to 20% that I change in the message, and then
That is not much. That's not a lot, to be
no,
honest.
no, and the trick is the model stays the same. We're not retraining the data, so that it's in a secure environment. The data doesn't get shared with OpenAI. There's no retraining because it's medical data, obviously.
So what do you if you send something through the API to ChatGPT? What is it that you share? Obviously, not any privacy sensitive data. I understand it, no names and etc. But what do you share with the model? Because you need to have some input in order to get output.
Sure. So there is sensitive data in there. So the first one is the instruction, which says, like, you are a medical specialist or a professional entity, and you are tasked with drafting a reply to a patient message, that is, and then all the do not come into play. Then the patient message, like what did the patient ask? What sort of answer should we formulate? And then there's an excerpt of the medical file. And the messages that are put in the patient portal, they are triaged in a few categories. So it's like, oh, this is a question about medication, or this is a question about a recent visit, or this is a question about results of a study coming in. And then behind every category, there is a different prompt. And that prompt, the main thing they differ in is what sort of information from the patient file you send along. So if there's a question about medication, obviously you need to send the list of medication that the patient is using with the prompt. Otherwise, the model won't be able to say anything sensible. And you will also need to add the medical history, because that makes sense. It can correlate which medication is probably for which condition, or it might even preclude some medications from actually being on that list. And then you get response. So the model doesn't learn, it doesn't improve, but what can be improved is the way we ask the question or the category we assign it to. So which prompt, which question, and which data from the medical file do we send along to the model to answer the question? And that is where the tune-up or the fine-tuning comes in, where below every message that that is drafted, the provider can say, like, this is a good, this is a bad message, with a line like, okay, and this is why it isn't helpful or it is helpful. And then over time, we will have to change and alter the prompts to become more appropriate.
So it's not really machine learning; it's actually people changing the prompts. It's data collection and using that to improve what you're doing.
Yeah, and that's one of the things that we're trying to set up right now, is to have a decent process for periodically changing the prompt and being able to test it, and make certain assumption about whether it is an improvement or not. So the prompt engineering is really the biggest question from an implementation point of view.
And sorry.
No, sorry. I was saying that the biggest is probably getting the people to know, like, these are these models. They behave differently from the type of machine of clinical decision support or other forms of support you're used to. They're not deterministic, but probabilistic. You're not going to get the same response. So that's probably even a bigger challenge, because there's a lot of education involved to get people to know, like, these are new entities you're going to find in your clinical workflow, and you need to know their limitations and their possibilities. So that's an even bigger challenge. Yeah.
In a second, I would like to learn how you educate doctors and nurses about this. But before that, do you have somewhere like a filter or a handbrake for personal data coming out of the medical file accidentally? I mean, it could be somewhere in there. We know medical files are not always perfect. Sometimes you copy paste something, put it in the wrong category, and then there's something personal in there. Is there somewhere before it goes into the API a filter that checks on GDPR related information, or it just goes straight away from the medical file, from the category to the API?
So the prompt, along with the information that's contained within the file, they're called smart links in Epic language, which are just variables or calls to specific sets of information. So, for example, the medical history list, there is a smart link that will generate a textual output of the medical history of the patient. As long as you don't call for the patient name or whatever, it won't contain that particular information. And that is deterministic, so there isn't a lot of variability. You can predict what sort of information is in there. You mentioned the GDPR, but the server is in I think it's in either Amsterdam or in France.
So it stays in Europe.
So it's in Europe. So it doesn't matter. I mean, obviously you want to limit the amount of sensitive data you send to the absolute lowest possible, but we can send the data and we can process it. It doesn't get retained. There's no cache. There's no log. There's just a one-time call within a secure environment, which is the Nebula cloud platform, which runs on the Azure servers. And after that, the information is gone, and the output is just sent back to the hospital.
But if you send it to GPT-4, you're calling the model, right? You're
no.
So something goes out there through the API to the model in order to generate an answer.
Yeah, sure.
Right, and that's OpenAI, correct?
Yeah, but it's an instance running in Europe.
Okay, it's a separate instance.
So it's a securely contained instance, and that's one of the requirements. Otherwise, we wouldn't be able to send medical data at all. So one of the conditions, and Epic took care of all that for us, is that they set up the
Mm,
cloud platform here in a secure instance. They have they've got a strong strategic partnership with Microsoft, and they arranged for the secure environment in Europe to be compliant with all the laws and the security mitigations that are required of us. Yeah.
that is very impressive. I have to be honest, because that's one of the worries. If a lot of companies are using the API and sending their stuff, basically they have no idea where, um,
No.
and
Uh,
making big mistakes, putting stuff in there that shouldn't be in there, or information.
No, no, right. So no, that is one of the big requirements, and that one was taken care of first by Epic and was uh, reviewed by our chief information security officer, obviously. And while it still feels exciting, it was okay. They had all their stuff in order.
Well, that's good to hear. Now to the training or retraining the medical professionals and the nurses to change their mind, because they probably find this scary, using a model to do this. It's
Yeah, I'm not sure whether they find it scary. The people I spoke to, so I do these presentations in house right now. Try to see how people respond. A lot of people are focused on the positive side. So this could save me work, or this is really awesome. I've been playing around with ChatGPT in the browser, and I've seen its capabilities, which have amazed me. And now it's integrated in my workflow. So they're really excited about the speed at which we're able to implement this in our own environment. And the thing is, they can work around it easily because the only difference is that they've got this in basket. Uh, um, and when they click the patient message, they now see a draft response, which has two buttons: start with the draft or start empty. So if you don't want to have anything to do with it, you just click start empty, so you can work around it.
a bit like Microsoft Copilot.
It is. I think it's inspired by Copilot as well. So it's not very intrusive. Um, it doesn't require most new technological capabilities over the past few years for medical professionals have meant for them to have to change the way they work in order for benefits to arise, even if they usually don't arise. And in this case, they can basically keep working the way they always done, and it's fluid enough to facilitate them without them having to change their behavior, and that's a big change, I think. So it's an easy sell. I think the main challenge lies with getting people to understand that there's a difference between deterministic or imperative programming or algorithms and these more probabilistic models that can have variable outcomes or are able to hallucinate or confabulate. So they have to get to know what sort of entity this is and what they can do and what they can't do. Um, and I'm not sure if we're going to have to convince them that they're capable of more than that what they're willing to believe, or whether they expect more from the model. So whether they will be disappointed by what it actually does. It could go either way.
That's well, I'm curious to see what they make of it. But if you look at that, and how much do you project if this is fully implemented in a department or in the whole hospital? How much time is it going to save the doctors on a yearly basis in terms of a percentage?
So that I think that's a difficult one because we're only looking at one use case right now, which is the messages. And part of it is messaging. How much time are people spending with the inpatient messages right now, or the patient's messages right now?
Or a lot of the times they're not answering. They get the message, you don't have the time.
Yeah, that's. I think the response time is one of the parameters to look at. Like,
Uh-huh.
how long does it take for people to actually come around and make a response? I know that would be for me one of the parameters I'd be looking at. Um,
But
and then
ideally, if you look at ideally, let's say it's fully implemented and it works, everybody's is enthusiastic and working with it. If you look at ideally, how much time could it save? Just this use case. I'm not talking about all the future use cases
no,
we'll
sure.
talk about
So
later.
right now, I think average time of writing a message, which is a short condensed version, might be 5 to 10 minutes, depending on if you have to look in, do chart abstractions, see what's happening in the chart. So 5 to 10 minutes. If we consider that maybe is reduced by 80% because a lot of boilerplate is taken away, that'd be a nice gain. So a few minutes on a message, and then I think there was 60,000. I don't. Oh no, I'm not sure about how many messages we are sending a month. So it's a bit of a calculation. It's a bit of a stretch. I think the other use case is more easily put into numbers. So that's summarization, for example, because these models also excel at summarizing information.
Yeah.
And this, I mean, the messages is a great first use case, but it's not the one I'm most enthused about. I think where most of our time is going right now is preparing for an outpatient clinic and having to review like 30, 40 notes of different specialties. I work in an academic medical hospital, so most patients.
Complex cases.
Right. So they have a lot of comorbidities. They see a lot of other people, other care providers, and I need to get updated soon before I see them after 3 or 6 months. Like, okay, what happened in the meantime? What's relevant for me? And how that works right now is that I would have to click every single message because we're still not very good at this at registering problems or all the issues in a discrete fashion. So it's mostly just free text. So I have to review all that free text and see if I can find the relative tidbits in between. And what the summarization feature does is it takes, for example, all the messages since the last visit, and I can enter a lens. I can say, okay, whatever is relevant for an ENT physician, I can just do that in a textual fashion and then get a summary, which can be point-based. And it will actually provide references. So it will make a statement like the patient had a heart attack and is now on anticoagulants. And it will have a reference where I can click and I'll see the part of the note that was extracted from. But especially the lens feature is very useful because I can say, okay, this is a patient and he has chronic rhinosinusitis, and I want to know only the things that are relevant or pertain to this problem. It will leave out all the other stuff. Now, this becomes a little bit more exciting about the question, like, how sure can we be that it doesn't leave out other parts of the message or information because it's making that decision on itself. And again, the end responsibility is with the physician. And the difficult part is quantifying the difference between what would the physician have done were it not that these 40 messages have now been read by an algorithm. He or she would not have read the 40 messages in its entirety itself. So I think it's going to improve the amount of information that we have before we start a consultation. But yeah, you could also say like, okay, maybe it has left out certain parts that are relevant, but we don't know. And that's going to be a lot more interesting discussion, I think.
Well, one of the questions I have about that is if you have an LLM or AI or whatever you want to call it running in the background, because that's basically what's happening, and you have all this data. I did an experiment for a convention where I was a speaker, a neurologist convention, where I got 5 cases from the lead neurologist who was organizing the whole convention. And I was supposed to take all these neurologists out of their comfort zone to show that with AI or with an LLM, you could do stuff. Not that they would be replaced. So I asked it as a consumer or a patient would ask it, please give me 5 differential diagnoses with this, basically the summary of not summary, actually a dump of the patient file. And there was no names, nothing, no reference to a patient. Could have been any patient. So it was safe. And I asked it to give it to me, a couple differential diagnoses. And in 4 out of 5 cases, the right diagnosis was in there. But it came up with alternatives that people said, wow, we would have never, ever thought about this based on this information because this is so far away, but it's actually a viable option. So what happened was, what I was wondering is, one, okay, the summarization is great because I remember my dad, like you said, reading the evening before the outpatient clinic, reading all the information on the patients, preparing for. He saw 100 patients a day, so you can imagine the work that went before in that. He read that. He had a photographical memory, luckily. Otherwise, it's undoable. But the thing is, what if AI would tell you, well, new blood results came in from the lung doctor or something else, and it's not for you. You didn't ask for it, but it might have an impact on what you do. So it continuously, based on new data that comes in, generates a differential diagnosis, which might differ from what the diagnosis you have, but something you might need to look into or ask questions about in the next visit of the patient, based on new data from any other doctor in the hospital. Of course, if he goes to a doctor in another hospital, you're you have a problem because you don't get the data.
Yeah. So
It's a thought. It's just a thought.
it's a very good thought, because that's actually what the summary feature does. It also looks through a lot of notes which contain, for example, lab values or other stuff that people put in the note, that I as an ENT physician wouldn't normally look into. And because I've asked it to focus on anything that's relevant for me or my problem that I'm treating, it will do exactly that. It won't put out a differential diagnosis, because you said no, we don't want you to do anything that makes you a medical device. But it will put forth, like, this is relevant information for you. It will leave it to me to see why it's relevant, but he
Yep.
knows it's relevant, or
But
he or
that's
she.
but that's how you ask the question. You could ask me the question. Give me the information that you would use to come to that would lead to a differential diagnosis.
Exactly.
So you're not, it's the way around it. You're not
Yeah.
asking for the actual diagnosis, and you need to look for, okay, what's connected, kind
Right.
of diagnosis.
We're asking it specifically not to think, well, it would probably do so, and it probably would do so better than the average physician at this point. But this is the part where we've set a line, because if we cross that line, we get a whole a nightmare of legislative discussions coming in. And I'm sure we'll get there within a few years, seeing how fast these developments go, and especially when we go from more generalized models to more specific or clinically oriented models.
Yeah.
I think making up a differential diagnosis upon every available data point in the system is going to be a computer affair in the future. It's not going to be a human thing.
It's
We'll simply,
impossible.
it's impossible. There's so many variables, and already, if you look at the vast amounts of medical literature that are being generated, it is impossible, even within your super specialized field, to stay up to date properly, because there's just so much information being gathered about all the different relationship correlations, and these models are able to train on all that data and be able to spit out conclusions. But this is where technology is exceeding our ability to regulate or think of how we should regulate, or we want security above all, even if we already think that these models are probably doing a better job than a human being at some aspects of it. And the same goes for summarization. It's probably a better summarizer than any human being or physician is. Yet we are, sort of treading, or we're going close by that part where it becomes a medical device in that sense.
And is that sort of slowing down innovation?
It's risky. So we've got the AI Act being developed in the European Union. And
EU?
one of the reasons that we want to go fast in this regard is because we want to show what sort of benefits these technologies have, for them to be input for the discussion that's coming. Because we all know that the problems that the healthcare sector is facing, it's mainly a lack of people doing the work, and this is by far the most viable option that is going to provide more more productivity per care provider. I think that's going to be the one thing that is selling this technology the most, because there will be a lot of people who are in need of care. There's too few people that are able to provide it, so it won't be a question of, oh, do we feel comfortable using this technology. It will be the discussion of, either we trust this technology and its imperfections and we're able to provide care, or you won't get care at all, or you'll be on some waiting list until the condition gets severe and
You need more care. It's more
very
expensive and
so
riskier.
that's going to be the discussion, I think, in the future, in the coming years. Like, okay, it's scary and we can't control it fully. We cannot explain fully how the model came up with the answer. But if we can say, like, it's that, or it's going to be no care, or even worse care, or delayed care, then which one is worse? And that's going to be, and one of the reasons to want to go fast on this is to have some samples out there, like, okay, this is what it's doing for us. Before you regulate it to death, we're able to improve productivity. The one question you've asked us to do in the healthcare sector, because there's just too few people to provide the care that we need as a civilization, and that's one of the reasons that we want to go fast.
Now I'm going to ask you a nasty question. In your maybe now it's different, but when you worked full time as a ENT, how many times, how many days a year would you actually work the amount of contractual hours you had well, in your contract, or more? So
Yeah, so
I know it's a nasty question, but
it's,
um,
I think it's for everyone. It's the same, especially physicians. They work 120, 1 to 140%.
okay. Now here comes my question for you. We know doctors are overloaded. I've got a lot of doctors that I know. They work crazy hours, and sometimes it's beyond what's responsible behavior, not so much from the doctor, but what hospitals demand of the doctors. And there's no choice because the patient needs to be treated. So it's either that or no care,
Yeah.
which is also not an option. It's exactly what you're saying in terms of technology. It's right now happening in terms of time and how much sleep you got, et cetera, et cetera. But having said that, if you have a tool that improves your productivity as a doctor or reduces the amount of time you need to spend on paperwork, right, or administrative work, there comes a certain amount of time available. Wouldn't it make sense to say, you know where I'm going with this,
Yeah.
right? My point being, I don't, my feeling is that it won't lead to um, um, not necessarily you being able to treat more patients. Well, technically, if you look from a hospital budgeting perspective, they now budget you working 140%. That's the whole thing. This is your productivity, and that's what they budget on. So next year, they want more, so you need to go to 150. This is the fundamental problem, in my opinion. Now, what if this productivity gain would be used to actually give you doctors back a life, a family life, and time to relax and, regain your energy? Because we tend to forget as consumers or as patients or as a society that what we ask from doctors is, if you see a lot of patients, especially in a academic setting, you see a lot of patients with serious conditions that possibly die more often than not, on average, compared to a regular hospital. I mean, that's very demanding emotionally also for a doctor. If I
Yeah.
don't know, you might not agree with me, but this is the way
No, I understand your question. I think they're actually it's the same issue, because if we keep stressing our workforce, be them doctors but also nurses, for example. I think with nurses it's even worse right now, with there just being too few of them to do the work, and a lot of other the support staff. If we keep stressing them in this sector, um, then they'll then will cease to be an interesting employer. And by the way, they're also leaving the field. I mean, young doctors are leaving en masse as well, because they're disillusioned with the amount of work that they need to do, the amount of autonomy they have, and the amount of time that's left for just having a normal family life. So they're looking for different lifestyle options, or part-time work. So if we keep the volume knob up and say, okay, this technology is going to enable working 100, producing 150 time, increasing productivity to 150%, we're going to lose people along the way, and that's going to be even more impactful on the overall productivity of the system. So in a way, they're the same question. I think part of the gains that these technologies will provide should go to uh, um, to getting back to 100% productivity for a physician, so a normal life work balance. Also, to keep it interesting for people to go into the field, because that's also going to be interesting. How many people will actually want to work at these jobs? If we keep asking them to work 120, 130%. Um, and the other one is burnout as well. I mean, if they're burned out, if they're sick at home, they're not putting any productivity out. I mean, these systems don't work autonomously. They facilitate, or they catalyze the output of a physician or a care provider. So we're going to need those entities. So I think the gains should be split, partly to increasing the overall amount of care being provided, partly to give a little bit of hours back to the physician and normalizing. And by the way, the one thing that this technology, if you string it together with certain other features, like for example, speech to text before we transform the text, that those are actually going to make the field more interesting again. Because right now I'm fighting 40% of the time with my monitor and my computer, and I'm not even facing the patient while he or she is sitting there right left to me. I could be facing them. So what we've seen with Epic do in the US is they've got ambient, which is a nuance integration where you just have a conversation with the patient and the other people in the room. It makes a transcript of who says what. Then the transcript is fed to an LLM. The LLM translated into a structural note. And then the other step would be to have the structural note be converted into discrete values. Okay, this is the patient said he or she has diabetes. It goes into the medical history field, diabetes. And then based on those discretized values and the treatment options you have discussed, it will suggest the orders as well. And you only have to, so the computer monitor's out of the way. You're just interacting with the patient. And then at the end,
It looks old school.
yeah, so it's like medicine was intended to, like an interaction between two human beings, figuring out a problem. And
You know what it's going to. You know what's going to do. It's going to reduce the amount of time you have to actually speak with the patient. Because I told you about my father. He refused to put a computer on his desk. He says, "I'm talking to a patient, not to a computer. We'll do that later." And the point was, the amount of time he would spend with the patient was much less than right now a doctor spent with their patients. But it was much more intense, 1-on-1, 100% focus. And the patient would go outside saying, "Oh, I got all the attention of the doctor." They forgot how long it was. Otherwise, you can't see 100 patients.
And that real connection, it counts double, triple in time because the patient will feel like they've been heard. And the most important part, it's fun again to do. That's what people go into the medical field for. They don't go into the medical field to fight with a computer. They go into the medical field because they want to help people, because they want to interact with people. And that does two things. It makes the field more interesting to go into. So that might help a little bit with the number of people working in the field. And you go home with a good feeling, like you've done the work that you set out to do, instead of
being swamped in administrative work.
Right, it's frustrating about the field when the computer saying no, the computer says no. Like, okay, this is the experience the average physician, and the one that I hear in our organization as well, has. We're over-regulated, we're over-administrating. There's IT everywhere, but it's not helping me get my job done better. And this technology has the potential to actually solve some of those problems for the first time.
So I have two additional questions about that. One, if you look at the cost, I mean, if you use it a lot, that you have a certain token cost, especially with OpenAI. And the more successful you are, the higher your cost. That's one part. And the other part is, and of course, how do you manage that? And the other part is, if as we said, the productivity gain needs to be divided in terms of care and time, private time for the physician, back to what you're being paid for, in terms of hours. How do you convince the higher management that you're investing a lot in a system that should give productivity gains as they would see it from a business perspective? And then you say, no, you're not going to get all of it. You're going to get an X percentage. The rest is going to go back to the doctor. And by the way, you need to change your budgeting, because you're now budgeting for 150 or 140% of the doctor's time, because that's what we're doing. We need to go back to 120%. So you're going to get less money, but we're spending more. How do you get that across to a board? Because that might be an interesting discussion, I presume.
Well, I think foremost the board member that I do this together with, which is Stephanie Klein-Nagelvoortschuit. She doesn't see this as a business opportunity per se at all. She sees this as an opportunity to alleviate some of the big problems in medical care. So
I applaud her. I applaud her. Please give my compliments to her.
That's a good start. So that's not what she's in for. So this is not about operational excellence at all. And I think the second thing is that the cost is coming down so quickly that I don't foresee it actually being that big of a problem.
Okay.
Right now, we're on GPT-4 model, which is very inefficient. I think we'll go to a smaller model that is more catered towards our use case. It's going to be even more efficient. But if you look at GPT-4 Turbo, and I think it was halving or even a third of the price of the tokens, I think that will go down, down, down as computing goes up, which it still does sort of exponentially. And then if you look at the cost of a care provider that is burned out at home or
Oh.
not being able to fulfill, or if you don't have the capacity to do surgeries, for example, if you're not able to see the patients at all, there's all kinds of things that make this business case become positive other than increasing productivity. So I feel like it's going to be an easy sell.
So what you're saying, you're actually using the hidden in productivity to make that go away, and actually then you gain a lot of productivity. That's what's happening. That's, or at
Sure.
least if I interpreted you
Yeah.
correctly.
So, and there's a lot of bottlenecks right now that are also making us less productive or making us less financially viable as a system, that could potentially be alleviated if certain things would just flow more easily. And another thing is like the transforming the free text to structured data elements, for example, is going to unlock an incredible amount of data that can be used to either optimize the system, or it can be used to do research, develop new products, develop things that could even be marketed. There's just so much potential, and it's almost a non-discussion for me if it comes to, oh, we need a business case. That having said that, we are intending for every feature that we roll out to have a follow-up to see, like, okay, what does it actually do? Does it cut time in half? Are people happy with it? Because we're not going to the features that don't actually valorize much, we're not going to go forward with those, obviously. So there is a system to see, like, is this valuable? Do either the patient, the physician find it valuable, or does it have a positive impact on flow in the value chain?
Or the
Um,
quality of care, because that if
Quality of
you
care. So yeah, quality could go up, productivity could go up, satisfaction for a patient and or a provider can go up. Um, yeah, there's so many positives.
and if you look ahead, let's move to the patient now, because right now, what we
Yeah.
talked about, the improvements are for the on the doctor's end. Eventually, that leads to improvements to what the patient sees and feels. But how are you gonna move this to the front end, to the patient?
So
Because
well, a good example would be, um, right now we're sharing a lot of information in the patient portal. So if the patient went to you, you have this clinical note. You can share that one. You can share the letter to the other care providers, but also the OR report, or the pathology report, which is all written in medical jargon, really. And it doesn't make much sense for the patient. So what you can do with the LLM is to say, make this understandable for a 5-year-old. So transcribe this message, and it does a wonderful job. So in the future, I even foresee you being able to chat with your own file and be saying, like, okay, the surgeon has set out his OR report, but what actually did he do? And I've read that sometimes they take out this piece of the bone. Did they do it with me? And you can just ask these questions and get an answer in natural language. Another use case that they have is where they translate it. We know that translation is already at a high level, but the LLMs take it even further, especially where, for example, questionnaires are involved. Where
you mean triage questionnaires?
So triage, but also just you've went to the doctor, or you have to prepare for your first consultation. If you go to an
Okay.
allergy outpatient clinic, then you have to fill out like boatloads of information, all the substance, what sort of responses you've had. Those are built right now either in Dutch or in English. But what if you are a foreigner and you don't speak either of those languages? You can now have the model translate them. It does have implications on how valid it is, but again, what level of variation will you accept versus having not filled in the questionnaire? So which becomes more valuable, either having the information with a small caveat that there might be a ambiguity in the way that the translation went off, versus having no information at all. But those are really going to be the questions that we're going to have to answer with these sort of technologies. Like, they've got so much potential, but if we stick with our current regulatory mindset and wanting to be sure about everything 100% of the time, then the entire system is just going to collapse in and on itself. So,
By the way, the translation part you can solve by having the model checking itself. So doing
yeah,
another prompt when it comes out, so translate it back and then see if it transfers the message, and always giving it in two languages. So for insurance or safety purposes, so you give the French translation, for instance, and the Dutch translation or the English, just to make sure that if the French one is not correct, then the other one is.
no, absolutely. So there's ways around it. There's ways to mitigate the risks, but I think
Exactly.
that the big challenge is not the technical part. It's the way we think about quality, the way we think about the level and amount of control we exercise over the way we do our work and we provide our care. Those are really going to be the ones that, from a philosophical point of view, are going to be challenged by these new technologies. And
That's interesting because previously you said you were training, and you had to engage these doctors to basically change their minds, and not the way they're working, to make their life easier, and to take the step or the leap ahead. How are you going to change their minds? I know you have a roadshow, you go around and
oh,
giving
sure.
presentations.
So I think selling it to the doctor isn't that big of a problem. I think it's selling it to the IGA, which is the Dutch quality. What is it called?
Yeah,
Inspection,
that's inspection for healthcare inspectors.
healthcare inspection. That's going to be going to be way more difficult, because I think you can demonstrate by doing studies on the output on certain test sets, like what does the metal perform like, and we can compare it to a human being. Um, the real discussion is the same with the autonomous car. If an autonomous car makes an accident where someone dies,
Who's
then
responsible?
it's yeah, but it gets taken off the road. Well, if we have an autonomous car that we know, like, yeah, it'll maybe once or twice in its lifetime it's going to make a fatal accident, so it can't be on the road. But with a human being, that risk might also be somewhere in that range, or maybe not that range. It's a bit high, but and we say that's fine because it's a human being. So the model needs to perform better than a human being, or be more in check than a human being. And that is a more philosophical discussion that we're going to have, especially once we tread into these sort of models doing medical device work. So they will be generating a differential diagnosis, or will be advising in a clinical decision support manner. And
I'd be
those are going to be very interesting discussions.
I'd be interested to do a sort of a hackathon where you compare a bunch of doctors with a bunch of medical prompt engineers, because I think that'll be a profession in itself. To be honest,
Yeah,
not regular. It's going to be very specific. You need to be knowledgeable about what you're doing or what you're asking, or ask it not to do, and compare the quality of the diagnoses. And I think um, it might have a shocking outcome that and nothing wrong with the doctors, but that the amount of time and the quality of the diagnosis might be better if well prompted with the data by the model, a model or models, um, and
once
then
we once we start training these, because right now we're still these generalized models. Once we start training them on all the medical literature, and yes, they will.
yeah,
I'm
but also incorporate information like which now you can't do. So if you ask me for my zip code, you can extract from a database the amount of air pollution. It's just an example. Okay. But then if you combine that with other data, you all of a sudden, okay, if you lived for that long in that air pollution, there's a higher risk of X, Y, Z. Hey, we see that in the blood, or we see that in the lungs, or what. So there is, and that analysis is almost impossible that quick to be made by people.
sure the
And
amount of data that can be processed to
exactly.
make a choice. is unimaginably larger for a computer, augmented by these models, and these are going to be multimodal models as well, being able to sift through all that information. And it's the same with seeing patterns in the data. I mean, currently we are still working with hypothesis-based research, so we need to come up with a logical construct of why would these two things be causally related. These models can make the weirdest combinations of variables and see in them certain correlations, and without overfitting, these could be used to predict certain elements, and that's also going to happen. That's the other part. Like these are the large language models, but then you also have got the more quantitative models, which are able to do predictive analysis, and those are going to take a flight as well.
And I imagine that if you do such a test with all these models, the IGE, the Dutch authority of healthcare, or healthcare inspection, they might actually understand that not using these models or not experimenting with them and implementing them in healthcare is actually a bigger risk, because doing that, you probably get quicker to the right diagnosis, which puts less strain on the medical system and drives cost down, not up, down, very rapidly.
But seeing as where we're coming from right now, which is it's very, we want to control it, we want to understand it. I think even in the MDR there is a clause that says you need to be able to explain how the model came to the result, which pretty much excludes most of these models because they're very probabilistic, and
99% is excluded.
yeah.
That's
So
because the EU AI Act says that, and they did some research, and 99% does not fulfill that.
yeah, so that's going to be difficult. But yeah, I think, and that's the most important part of it all, is to have that discussion. And that's why we want to go fast, is that we have these concrete examples to be able to show people something that is that is not something of a pipe dream. It's something that's real. It's in front of you already. You can see the benefits. It makes our argument so much stronger. Like, don't ignore this, because the real problem is the medical system collapsing in itself. And that's coming. That's approaching faster than we all think, and we need to let go of some old thinking. I think that's going to be the talk, and I'm hopeful that we'll have that conversation in time, and that people will see that, as you said, doing nothing or not using these models is actually a bigger threat than using them and thinking different about the risks that are involved in them. But again, these are what we're doing right now because that's important. None of this is as usage as a medical device, so it's not touching that. This is just to see if we can get the administrative burden lower. And I think the biggest benefit right now, where the technology is right now, that's something we can really do with this technology.
And yeah, one of the things I do see that needs some extra care is we come back to the bias. That if you start using it as a medical device or doing diagnoses, is that you need to be really, really well aware of what kind of bias is in there or not in there, what groups are not in there. Let's say we have refugees in the Netherlands of a certain origin, doesn't matter which one. We don't have them in our regular data. So our bias would exclude them. So anything they would have would not be suggested by the system because we don't see it regularly. So that's some of the things we need to take into consideration. I have no solution, but just the question. But I do realize that if you understand that bias is in there, you can correct for it, or you can add data that actually takes that into consideration if someone comes from some other country, which is not regularly in our data. Tom, if you could look ahead, and you can actually, because you're working with sort of futuristic technology. It can do a lot more than you're using it for now. What is your dream? You're an ENT, as a doctor. What is your dream? How would you like to work in a couple of years' time? I don't put a time limit on it because there's too many rules.
You're not putting it. So what I'm most hopeful is in the coming years is that doctors, nurses, other care providers will be able to provide care in the fashion that they envisioned when they started the field. They didn't envision working with a computer or looking at a computer screen. They envisioned working with a patient, having a real connection, and solving their problem, helping people out. So to bring back the field to its roots, that is the short term, I think. If we go a little bit beyond that, and it could be faster than we all expect, as there's this exponential curve underneath all of this. I think a lot of things that we do as doctors right now, and what we feel is how we provide value for the patient, is going to be stripped away from us in a way. I feel like, for example, the differential diagnoses, so making the diagnoses based on a lot of data, suggesting the next steps, or thinking about the next, or trying to combine it, or even multidisciplinary approaches where we're all sitting together. I think what you'll see in the future is virtual actors, virtual entities that are able to handle certain information problems of trying to combine different sources of data and information in order to bring that process forward, and advise on what the possible solution would be for a patient, is going to be so far from where we are right now that I'm not sure if we'd still be talking about doctors and nurses as entities, or more like system engineers or supervising entities, or a supervising role, that, and even that on that timeline might not be there anymore, and it'd be just human to human contact and interfacing would be what remains. But yeah, so I'm positive, and I'm also a bit apprehensive, because this is the thing that doctors, nobody likes to hear, that their job is going to disappear, or
But
it
is it?
makes
But
it hard to do.
is it going to disappear? Because someone asked me this weekend to comment on a post on LinkedIn, and it was a bit philosophical. But what if solar flares destroyed our AI? Basically, you cannot use an LLM anymore. And I didn't apply to doctors, but I was thinking while you were talking, it's like, okay, it's going to change. But I always ask the question, what does it mean for education? So how are we going to train doctors? In the future, that's knowing with what's happening with LLMs, but also what if it doesn't happen? Now we have to cancel surgery if the system in the operating room giving patient data from the patient file doesn't work. Right, you can't operate.
Right?
In the old days, you didn't have that. You would operate without a computer screen giving information on doctor, and still you would have probably the same survival rate, right? Or
So
so you
there's a
understand
question.
my question?
Yeah, it's a question about redundancy. So if you're talking about the solar flare, for example, it won't particularly take out just the LLMs. I think you'd have bigger problems with the entire food chain
It was a
being.
philosophical
I'm just,
discussion.
I'm just saying, like, we've already surrendered most of that redundancy of being human and being able to. We were at 8 billion people. We rely on so many things, and it won't be any different for this technology, I think. I feel that in 10 to 20 years, we won't be able to provide care without using these systems, so at least not on the level that we're used to by then. And that's totally fine. But
So
yeah, barring extinction level events.
no, but
uh,
it's more about the very complex stuff you would like an LLM to do. Yeah, processing data, come up with diagnosis you would otherwise wouldn't come up with. In the old days, people would just die because we don't know what they had, and afterwards, and when we would cut them open, we would see, oh, it was this or that, and we learned from it. But you would want the doctors not to be 100% dependent on just AI or LLMs, and be able to operate, not literally operate, but work even without a model, to have the knowledge, if you're specialized, to do what you have to do. And the AI or the LMs are the extra to make life easier or better or do the complex stuff. But I think the basic stuff you still need to be able to do as is or as was, in
sure.
order to safeguard
Yeah.
against whatever might happen. It's philosophy. Actually, I invited the guy to my podcast because I find it really interesting to philosophize. Okay, well, how are we going to manage that?
So I, I'm skeptical. We'll keep that hybrid approach for long. I think because of our natural distrust, we'll have that situation where the human being will be the supervisor of the algorithm, But after a while, when we see how well it performs and how much better, and that it's the supervisor is not really adding anything, it's like the algorithm. I think it was for dermatology, where if you had the algorithm make the diagnosis, you had a 95%. It was 95% correct. And it used to be that if you added a human, it'd go to 97%, and then they had an algorithm that would 98. And if you added the human, it'd go back to 94. So the human starts introducing more problems or errors, then it increased the performance. So yeah, maybe no. I actually feel if you ask me, there we're going to. We're going to atrophy, to descale to a level where, yeah, we'll be reliant on this technology and it'll be fine, because we're reliant on so many things. We're reliant on our entire energy infrastructure. If that one would be taken out for whatever reason, we'd have a very big problem as well.
Well,
I mean,
it is already a problem in Holland.
yeah, but I don't know how to farm, for example, so I wouldn't be able to sustain myself, and I don't think you would either.
no,
So
but you live in an area where you can actually farm. I live in an area where you actually cannot farm.
no, but I think it will be the same with this sort of technology. So yeah, we'll lose that redundancy, and it'll be relegated to the machine realm, and that's maybe fine. I mean, I can also envision a lot of dystopian outcomes. I mean, we've got a Fermi paradox for good reasons. Maybe this one is involved. I don't know. We'll see. It's an exciting future. That's the way I look at it. And in the short term, I mainly see my own profession and all other care providers being able to do what they like doing
I'm glad to hear that.
afterwards.
I'm really glad to hear that, because I think doctors that are enjoying themselves and are happy doctors are better doctors.
It's good for the patient as well.
Exactly. No, that was the point I was making. And also good for the marriages of doctors, because they have a very high divorce rate in the Netherlands, to be honest.
I have, yeah.
So I hope that goes down too for all the children involved. But
Yeah.
looking ahead, if I'd love to see what you come up with next in the near future. So maybe in half a year you come back and maybe tell me what the innovations are that you've brought to market and what they've brought, and looking back the things you did now, if they brought the improvements and brought down the
Yeah,
amount of
if
hours
it
the
works
doctors work.
out.
Yeah, it's interesting because everybody talks about the successes, and we know there's a huge amount of fuck ups that lead to the successes. It's not a problem. A fuck up is good. You learn from it. And
Yeah.
that's, if I could ask you, what was the biggest, I would say, mistake or learning experience, as I would say in a decent way, of this whole trajectory up to now?
Um,
Or what would you do differently with the knowledge you have today?
so far, I think it's been smooth sailing, because we are only now entering the period where we're going to scale up and have a lot of more physicians interacting with the system and going to get the feedback. I
Okay.
think that most of the learning right now is in the prompt engineering and just figuring out. I mean, I know classical programming, which is very easy. I mean, it's very predictable. But this is, it's like talking to another human being. It forgets stuff. You have to put things in capitals for it to think you're screaming it, and then it will listen better. I think that's the main thing that we're learning. Like, how do you interact with a model that, in a way, performs like a human being would? And
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 at the
and
same time, it's a computer.
and it's a computer, but we're simulating the way our own brain works, and you can see the same results as well. Like, if you instruct it, it's not a, if I tell you to do this, you'll do exactly this. The outcome can vary. It's like, no, it's not like it feels something, but it's like, oh, I'm going left today, going right today. So there's this flexibility. I think that that's just a very interesting phenomenon. And the one thing that surprised me the most, but as an overall observation, is how natural it feels to interact with these technologies, and how that might change interacting with digital technology overall for everyone, especially patients that aren't very tech savvy. That this is something you can just type it in normal language. You can use typos. You can do it in dialect. It still understands you. And that's also something I think from an interactive point of view for a patient is also going to allow for a lot more care at a distance, and be able to work with a patient portal.
You're basically making care, the use of care or the interaction with care and caregivers, you're making it conversational and have the computer as a filter.
Right, and
That's what you're doing.
you can skip all the barriers that digitization gives you. So yeah, no, it's just very interesting. It's a great time to be alive. I really like working with these type of new technologies.
Well, let's see if you're still this enthusiastic in half a year after
We'll see
scaling up.
it's all in shambles. Well, we'll
No,
see.
somehow I don't think so. My prediction is you're going to make, you will be technically be able to make big steps, and you'll have quite a few happy doctors. But my not my worry, but more you might run into some legal barriers that will prohibit you to go faster or as fast as you can or would like to go. And I think they should be taken away, those barriers, at a governmental level. So yeah, but that's my prediction. So let's see in half a year where you are at.
No,
And
that sounds good, and I think you're absolutely right. That's the biggest risk I see as well. But for me, it'll also be success if we have that discussion and that we're talking about it.
if I can help with that in any way through my network, please let me know. Because I think it should be taken away, at least allow you to experiment on a big scale without risking lives of patients. I think that's possible. And then, no, but if that can be done and there's no privacy issues, I think then you'll be gaining knowledge at scale. And that's where the magic is going to happen.
Sure.
And if it works for you, it works for any other academic hospital in the Netherlands. The procedures and the protocols are more or less the same.
Yeah. So what we're also seeing right now, there's 11 epic hospitals in the Netherlands. We're working on this together with ETZ. We are the first two to bring this into production, and the others are now following suit. So that's also going to give us a little bit more volume and a little bit of things to speak of. And we could probably do some multi-center studies on the effects, also from an economical point of view. Like what does it actually entail? What does it bring us? So it's we'll see. But I'm curious what I'll be able to tell you in half a year.
And do me one favor. Ask the patients. Keep asking the patients what they think of what they're getting.
It's also in the protocol. So we're
Okay,
asking
great.
the care provider, but also the patient. Like, what do you feel this message is like? No, obviously, because it's about the patient in the end. Sure.
I think that's a good way to conclude this podcast. It's about the patient.
And it
Tom,
will remain.
absolutely. Thank you very much for today. I really enjoyed it, and we'll see you in like half a year and see where you're at.
Cool. Let's do that.
Okay. Thank you very much.
Thank you.
Take care.